uh, just as before going to proceed, just let me know if you have any doubts. Jayant, Manohar, Nitesh, Raju, you all guys are in yesterday's part of yesterday's class, right?
Yes, sir.
Yes. Yes, sir.
Just yes, any doubts in understanding of the definition of snowflake?
No, sir.
So we have discussed basic level of information yesterday.
Yes.
Any doubts?
No.
Right. No, no,
No.
good.
Okay, super. One second. So we will discuss today uh, architecture of the snowflake. Architecture of the snowflake. One second. Guys, actually, we have a three layers in snowflake architecture. We have three layers in snowflake architecture. One is cloud service layer. Another one is query processing layer. Third one is database storage layer. Let me repeat once again. One is clouds. Guys, just I am suggesting you and recommending you after the each and every session, whatever we are going to discuss, the theoretical part and then code part, I will share you end of the session to all of you to your personal mail IDs. At the same time, just please prepare some running notes from your end also, so that it will be easy to rewind the things. Just make some notes from your end also. Fine.
Sure.
Okay. Yeah. So we have a cloud services layer, and then query processing layer, and then database layer. I am repeating once again. So why I am repeating once again and once again? This snowflake architecture is very much important. Damn sure you will get a one or two questions from the snowflake architecture in the every interview wherever you go, in all the companies. That's why I am repeating. So we have a cloud services layer, we have a query processing layer, we have a database storage layer. Now we will discuss one by one. So what is this database storage layer will do? What is this database storage will do? Storage component this is a one of the database storage component. This is one of the component of the snowflake. Nothing but, so we have a like storage and then compute component like that. This is a storage component of the snowflake. And so whenever you load the data, into a snowflake, automatically the data will be stored in a continuous micro partitions. Guys, what is the meaning of this micro partitions? Means, see, if you load, if you have a some 2 TB of CSV file, 2 TB of CSV file in your source system, when you load that 2 TB of CSV file data into a Snowflake data warehouse, automatically that data will be stored in the tables. Automatically the data will be stored in the tables, and then from the tables, in a database storage layer, in storage component, so we have a micro partitions. Where your business data is going to reside into the component. So the least component of the storage layer in the Snowflake is micro partitions. When you store your data in a Snowflake, automatically the data will be stored into a continuous micro partitions. Each micro partitions will be having the size 50 to 500 MB. 50 to 500 MB. Fine. So apart from these micro partitions, the data will be stored in the columnar format. Data will be stored in the columnar format. Data will be stored. What do you know? What is the meaning of this columnar format? Yes.
Means column format.
Yeah, column format is. See, first, let me explain you what is the meaning of the micro partition. How it looks like. See, this is the micro partition structure. I will tell you what is the advantage to have the data in a micro partitions, and also what is the advantage to store the data in a column format. See, if you speak about the traditional database or a data warehouse, data will be stored in a row format. In our traditional data warehouse or a traditional database. For example, traditional data warehouse, if you consider a SQL server, where in a SQL server RDBMS or else in a SQL server data warehouse, the data will be stored in the tables in form of columns and rows, and then so the data will be stored in the form of the rows in a traditional database or a traditional data warehouse. In case of a Snowflake, the data will be stored. Stored in a columnar format. I will tell you that one. See here itself the data. I will tell you. See, this is one of the example. This is the one of the example of the table. So we have a column called type, name, country, date. Type, name, country, date. The data is stored in a. So this is the traditional structure of the table. So data is stored in form of a column, and then rows. See, we have a type column, name column, and then country column, and then date column. When the data is loaded into the Snowflake, the data will be stored in a continuous micro partitions. This is a one micro partition. This is another micro partition. This is another micro partition. This is another micro partition. Within these micro partitions, your table data is going to loaded into multiple micro partitions. If you see here, the column, type, name, and then country, date. So this is our traditional structure. In case of your Snowflake, see, the data is storing in a micro partitions in column format. See here, the type is here. Type is one column, and the name is another column. Country is another column. Date is another column. See here, type, name, country, and then date. This is a row format. So this is a column format. So your first record, first record type is 2. See here, type is first record is type is 2. Second column, name is A, and then country, first record is UK, and then date, first record is 11/12. So what is the advantage of this having the columnar format means, if you want to search a data, instead of searching a whole rows in a whole columns, just it will traverse only in single direction instead of checking the all the data, from your all micro partitions, so that you can able to retrieve the data in a very faster. As I mentioned earlier, the data will be stored in a micro partitions and compressed way, and then optimal way. So this is what you can able to pull the data very fast from the Snowflake. See here. Suppose uh, if you want to search, like type equal to or name equal to y, see y is available in micropartition 3 and then micropartition 3. So if you write a query, select star from table where name equal to y. So the value from the name column is available in the micropartition 3 and then 4. So what it will do, if you hit a query into the Snowflake data warehouse, instead of searching all the micropartitions, it will go into the particular micropartition in a column format. It will go into the particular micro partitions, and then it will retrieve the data from the from the Snowflake data warehouse for you. So what is the benefit here? Suppose consider for your one table, if you have a n number of micro partitions, the data is table related data is stored in n number of micro partitions. If you are searching for the particular set of the result set, instead of searching the n number of micro partitions, directly it will go into the particular micro partitions, and then it will retrieve the data. So that what is the benefit here? Instead of searching the all the micro partitions, it will go into the particular micro partitions, and then it will retrieve the data, so that you can consume the execution of the time of your SQL code. Then how this Snowflake will know? How this Snowflake will know? If you write a select star from table where name equal to y, then it will go into the only particular micro partitions. How the Snowflake will come to know that the y is available in the micro partition 3 and 4? So we have some metadata table. Suppose when you store a data into a table, automatically the data will be stored into the micro partitions. That micro partitions will be having the for each and every micro partitions will be having the serial numbers for the micro partitions. The serial number and the micro partition details will be written into some metadata tables. There it will mention that this micro partition is having the data from this range, and then from this table. So using that metadata tables, when you query for your table, then it will check the metadata tables, and then so based on that it will identify the which micro partition has the data for your query, and then directly it will go into the particular micro partition, and then it will bring the data for you. So that instead of searching all the micro partitions, instead of searching the n number of micro partitions, directly it will go into the particular micro partition, nothing but micro partition number 3 and then micro partition number 4. So it will save the to search the remaining 2 micro partitions. It will go into the directly 3 and 4 micro partition, and it will bring the data for you. And one more thing is, so as you have a data in column format in Snowflake, instead of searching in your suppose if you write select star from table where name equal to y, it will come into the name column, and it will traverse all the records, and it will identify the y, and then it will bring the entire record for you guys. So this is and all. It will take the long process to search the data and then return the data. So to overcome all these things, in Snowflake they have designed the architecture in a very simplified manner. So whatever you want, suppose if you want to y, only it will come, and then it will search into the only this way, and then it will bring the data for you guys. So this is about the database storage layer in the architecture of Snowflake. So whenever you will, once again I'm repeating, just make a note down somewhere, guys. What is the meaning of micro partitions? What is the meaning of column format? So what is the meaning of this database storage layer? How the data is going to store? So everything you need to know, and then whatever we are discussing here, just if you explain all these things, this is more than enough, guys. See, database layer is this is one of the component in the Snowflake where you are going to store your business data into your Snowflake. Whenever you load the data from the multiple files from the different sources, obviously the data is going to store in a Snowflake in a tables and in a micro partitions, multiple micro partitions format. Whenever the data is loaded into the micro partitions address and the details will be available in the metadata tables in the Snowflake. So by using that metadata tables, if you query on a particular table by using the address of the metadata, by using the address of the micro partitions which are available in the metadata tables, directly it will go into the particular micro partition and then it will bring the data for you. So instead of searching the n number of micro partitions, it will go into the particular number of micro partitions and it will bring the data. So this can be called as a optimal way. So instead of traversing all the things, so directly you are going to the particular things and bring the data so that you can able to see the robust performance comparing to other data warehouse. So this is about a storage layer discussion, guys. Any doubts here? This is the storage layer. Any doubts here? Yes,
Sir,
I need a yes.
that metadata tables contain all the information about the micropartition, right?
Yes, address of the micro partition, and then so it will be having that address of the micro partition. Yes, correct.
Okay. Yes.
Guys, any other
Here
question?
one more
Because
doubt.
yes,
Sir, in the traditional database Oracle, like we have row IDs and some other things, right?
okay.
So based on that also we'll get the query in the quickly, right? So what is the difference between that row ID and here that address of the metadata table?
Row ID means I didn't get you. May I know your name, please?
Sir, so now if I'll store the data in one row in the Oracle table, it will save with one address, address of the not primary key.
See, I understand your question. See here, actually, see row ID when you create a index, not only Oracle, whatever the RDBMS, traditional RDBMS, when you store the data in your traditional RDBMS, on top of that, if you create a indexes on the table, then only this row ID concept will come into picture, guy. Actually, see, if you don't create any indexes on the table, then this table can be called as a hash table or a heap table. See, until you create a indexes on the particular table, you will not be able to see the address of the any data in your RDBMS tables. If you create a indexes on that, if you create a indexes on the particular table, so it will create a balanced tree in the database based on that. That is different concept. Again, we need to go to that concept. We need to discuss half an hour on that. But yes, for your question, if you create a index on that for that particular data pages in your database, so there in RDBMS, whatever we have a micro partitions in the Snowflake, there in RDBMS data pages where the data is going to store. Until you create indexes, your data will not be having the row ID. Fine.
Sir,
Hello.
yes, sir.
May I know your name? Your name, please.
Raju,
Raju. See, I understand your question. Until we create a indexes on a table in RDBMS, row ID concept will not come. Row ID or key ID. Yes, once you create a indexes on your column or a table, then your row ID will come, and then again that balanced tree concept will start. So that is different again. So here
okay.
by default, when you store your data, by default you will maintain address in a metadata instead of searching all the n number of micro partitions, you will go into a particular micro partition. Have you got the differences now?
Yes, sir, I got it.
Clear or not? Still, still if you have any confusion,
Clear, sir.
let me know. I will tell you. Clear, huh?
No, no. Clear, sir.
Super, super, super. Now next. So we are done with the database storage layer discussion. We are done with the database storage layer discussion, and then we'll go to the query processing layer. Query processing layer. So how does database storage layer is important in your Snowflake? This query processing layer is also very much important. In single word, I can say this query processing layer is virtual compute warehouse. Virtual guys, I can recommend you to make some running note also. I will share this content after this end of the session. After this end of the session, make some running note also. So this query processing layer is a hardware component which can be called as a virtual compute warehouse. Virtual compute warehouse. Virtual compute warehouse. Fine. So how your database storage is a storage component. This is virtual warehouse or query processing layer is also compute component. Compute component అంటే hardware component, the combination of RAM, CPU, motherboard, everything. So this is very much important. This query processing layer or a virtual warehouse computer, virtual warehouse component is very much important because how you are going to store a data into your storage component. This virtual compute warehouse, what it will do, whatever the operations you do, in your Snowflake data warehouse, whatever the operation, if you are loading a data, if you are submitting your workloads into if you are submitting your workloads into your Snowflake, what is the meaning of workloads? Workloads nothing but a number of SQL queries. If the number of users are connecting to your Snowflake and then they are retrieving your data, right? If you are processing a large volume of data, if concurrent users are accessing your Snowflake data, whatever the operations you do, your virtual compute warehouse components are very much required, a which are a hardware component in your Snowflake, which are a hardware component in your Snowflake. So whatever you do, data load or the data processing, data retrieval, your hardware resources are required to process your request, to process your request, to process your request. See here, virtual warehouses or hardware resources can create the multiple right. See here, till here you are clear, huh? I will tell you. See, this query processing layer is a virtual warehouse which is a compute layer, and then this is a hardware resources. This is a hardware resource to your Snowflake. It will be useful and it will be required to process all the requests for your all your requests in your Snowflake. The requests are either you may be submitting your workloads or queries, or you are accessing a data from the retrieving a data from the Snowflake, or loading the data into Snowflake. To process all these requests, your virtual compute warehouses are required, which are a hardware resources. Till here, this is the basic concept of this query processing layer. This is clear or not? So if you clear on this, next I will go into the next points in the query processing layer.
Okay, miss. In the query processing layer, virtual warehouses is the hardware component which
Hardware
process
component.
the request.
See, in your traditional database or a data warehouse, you will be having the CPUs, memories, and then everything, right? Like
Right.
that, this is also a virtual warehouse. Virtual warehouse is a hardware resources in your Snowflake. So just you can't able to see those physical devices, those things and all. This is architecture. I will show you how to create the virtual warehouses, how it looks like. So you need to create virtual warehouse. This is also one of the object, like how you are creating a table. So this virtual warehouse is also one of the object in your Snowflake. You are going to create. You are going to create a virtual warehouses. Fine,
Okay.
guys.
Yes.
So now, so you dedicatedly you can able to dedicatedly you can able to create a separate virtual warehouses for the each project or each team. Please make a note down. Dedicatedly, you can able to create a virtual compute warehouse or virtual warehouses for each project and each team separately. So whenever you are going to work with the Snowflake as a particular team or a particular project, you can able to access only your project related virtual compute warehouse, so that there is no dependency between the each and every virtual compute warehouse. You can able to do your tasks very easily, and then you can able to execute the things very fastly, so that you can able to see the result very faster. Okay, fine. And also, see, I told you can create each virtual warehouse for each process to improve the performance and make the independent. These are the independent components. So we have a two types of virtual warehouses: single warehouse and then multi-cluster warehouse. Single warehouse can create with the different sizes. Multi-cluster warehouses can create with minimum and maximum clusters. So with minimum and maximum clusters. Yesterday I told you. So yesterday I told you actually single warehouses will be created with the different sizes, and then multi cluster warehouse can be created with the minimum and maximum number of customer clusters. We will be having the separated discussion on the virtual compute warehouse. So where I am going to show you what are the different sizes are there, how the pricing will be happening, and what is a multi-cluster warehouse, and then what are the options we have, how do we create, everything I am going to show you. We have one separate session on the virtual compute warehouse. We will see more details on, because this is very much important, and then you will get the multiple questions on this virtual compute warehouse also. I am going to take one separate session on the virtual compute warehouse. We will see the in detail details of the component. So for now, so you can able to see, we can able to tell that this query processing layer is a virtual compute warehouse, and then virtual compute warehouse which is a hardware resources to your Snowflake. Guys, any doubt in here? This query processing layer. Hello,
No, sir.
clear, right?
Yes.
I will share you this content. I will share you this note also once completion of this discussion. So next layer is a cloud services layer. So we are done with the database storage and then query processing layer discussion, right? Agree?
Yes.
Yes,
Hello.
sir.
Yeah. So we have a cloud services layer. What is this cloud services layer? You see here. So this is a top layer. This is a very much a top layer, and then it will handle the entire Snowflake, guys. This is the very first layer in your Snowflake architecture. So this is the key component in your Snowflake architecture. It will take care of everything of your Snowflake till when you create a account in your Snowflake. When you create your Snowflake account, so your username, your password, and your account details will be taken care by your cloud service layer. So all the access control related information will be checked, managed by your cloud service layer. When you log in into Snowflake, when you log in into your Snowflake account, initially your cloud service layer will be cross-verified with your details. Then only it will allow you to log in into your. Then only allow you to log in into your Snowflake. So without this layer, your Snowflake will not work. So this is a top layer. This is very much important layer. It will take care of your access control related things, and also whatever you store the data into Snowflake, whatever the data is your processing, whatever your workloads are executing or queries are executing, your cloud service layer will be managed, your storage component, and also your virtual compute warehouse also. Everything will be managed by your cloud service layer. See, if you execute one query in your Snowflake, till once you hit the query in your Snowflake data warehouse, till you get the result into the end users, entire thing will be taken care by. What it will do, it will receive the request from the user. Suppose Razu is executing one SQL query in Snowflake. When the Razu is started to execute the SQL query in Snowflake, what this cloud service will cloud service layer will do? It will parse your query. What is the meaning of parse? What is the meaning of parse? Parse nothing but it will check the syntactical thing, and then if everything goes well, then it will send this request will go into the next level. So when you hit the query into your Snowflake, initial layer, cloud service layer will accept your request. It will pass the query, and then it will pass into the next virtual compute warehouse. Layer. There you will be having the cache. Cache nothing but this is one of the memory. Already, if the cache is available, if already cache has a data for you for your query in the virtual compute layer, then it will return the data from the cache itself. The cache is don't have in virtual compute warehouse layer, then the request will go into the your storage layer where the data is going to store in the Snowflake. So from there, the data will be returned into the your cloud service layer. So what I mean to say, cloud service layer will accept the request, and then it will push into the next level, and then it will bring the data, and then it will submit into the end users. So this is one of the things, and also remaining things it will take care of the infrastructure manager and then metadata manager. I told you metadata, those things and all, whatever the metadata tables will be having, those things and all it will taken care by your cloud service layer. So this is about the cloud service layer, guys. Then now we have discussed database storage, and then query processing, and then database cloud service layer. Guys, any doubts in this discussion architecture? Hello?
Good, sir. Good. Yeah.
Good, right?
Yes, good.
Yeah. You can contact the institute. They will share you the material. They will share you whatever whatever we are discussing here. This material, everything the institute people will share you guys. Just contact to the institute guys, and then ask for the material, and then they will share you this material, guys. Is that fine? So tomorrow we will be tomorrow we will discuss on the in detail of the virtual compute warehouse, and also how the pricing is doing, and then what are the different editions are available in the Snowflake. Tomorrow we will continue with that class, guys. Is that fine?
Fine,
Yes,
sir.
sir. Sir, I
Yeah.
have one question. Sir, can you practically a small query and how to
Sorry.
store it? Miss, can you give one example how to store the data in the column, and what mechanism they use like metadata how data is address is stored in the that
Metadata
metadata.
metadata tables I will give you, but actually when you store your data into a Snowflake, how the data is going to store in the Snowflake, that we can't see. Actually, we can't see that one. Actually, the internally it is happening,
Okay,
but
okay, okay.
we can able to see the metadata, how the data is stored and what is the address. We can able to see the metadata as part of the course. I will give you that metadata tables.
Okay, sure.
Fine. Any other questions? Any other questions, guys?
Sir, we are loading to files in same like SSIS packages like we are here using.
See, in SSIS package, what you will do, so you will have you will having the some CSV files in your some shared locations or in some
Yes.
different sources. From that CSV files, initially you will load the data into your staging tables, right? So from
Yes.
there, and then on top of that staging tables, you will apply the lot of transformations, or you will write a number of stored procedures on top of your staging tables, and then required data you will load the data into your target tables which are available in the production servers, right? That is the thing happening in your SS package, correct?
Yes.
In Snowflake, what you will do, the advantage of the Snowflake is instead of loading a data into your staging tables, directly you will load the files into Snowflake. So from there you can able to do a ETL. The
Hello.
that is the advantage. Directly we load the files into Snowflake.
Okay.
So once you load
Oh.
the files into Snowflake, so from there you can able to do the ETL or ELT, whatever you want. So that is the advantage
Okay.
and beauty of your Snowflake. So in case of your on-prem, SQL Server, SSIS, you can't able to load the files. You can load the data from the files, but you can't able to load the files into your SQL Server, right?
Yes.
You got the difference.
Yes.
That's what there's a very much beautiful concepts and beautiful advantages are there in the Snowflake case actually. Clear?
Clear. Thank you.
Shall we continue tomorrow?
Yeah,
If
sure.
you have any questions, you can ask me, or else we'll continue tomorrow.
Yes, sir.
Yeah. Thank you, guys. We will meet tomorrow.
Okay.
Yeah. Bye.
Bye.
Thank you, sir.
Yeah, thank you. Bye.
Fine. See, single warehouse nothing but it will be having the different sizes, right? It will be having the different sizes. So based on the usage and requirement, we can choose the size and create the warehouse. I will show you. So what is all the options. And second one is multi-cluster warehouse. Multi-cluster warehouse is we have a see here 1 second. Multi-cluster warehouse. We have a mode and we have a scaling policy. Mode scaling policy. This is standard and economy. Standard and economy. See? Standard and economy. So here auto scale and then maximized. Auto scale and maximized. The combination we can create this multi-cluster warehouse like this combination. don't get confusion. I will explain all these things. Maximized. Fine. So this is the best practice. Now let me explain one by one. So I am discussing about the first one, auto scale and then standard. If you select the auto scale, see, first of all, what is the meaning of this virtual warehouse? Nothing but this virtual warehouse. Once again, I'm repeating you guys. So the way the virtual, this is the virtual warehouse. How you are going to create a virtual warehouse? See, this is a single virtual warehouse option. You need to provide your virtual warehouse name, and then you have a different sizes. This is a single virtual warehouse. If you come down, you have a option multi-cluster warehouse. If you select this multi-cluster warehouse, you have these many options. I will tell you all these options, and then what's the purpose of these options. First of all, this virtual warehouse is a Snowflake component. So which is the hardware component to your Snowflake? Yesterday already I have explained this, which is a hardware component and which is very much essential, for your all the tasks like data processing, data loading, and data retrieving, and then while submitting your queries to perform all these activities. Your virtual compute warehouse is very much essential. This is a hardware component, purely hardware component. So this is the single virtual warehouse, and then this is multiple single virtual warehouse. Completely, you will create a virtual warehouse, and then you will select the different sizes: small, x small, medium, large, x large, double x large, and the triple x large, like that. So based on the requirement, you will select the different sizes and create the virtual warehouse. In case of a multi-cluster warehouse, you have two options. You need to make a note down, and you have to remember all these things, guys. You have two options: mode and then scaling policy. In mode, you have two options: auto scale and then maximized. In scaling policy, you have a standard and then economy. So what is the meaning of this auto scale? And then standard? So when you select this option, you will be having the minimum cluster, maximum clusters. You can give maximum clusters. You can give minimum cluster is 1 and maximum cluster is 5. And then, so this is mode. This is mode auto scale. And then standard. This is scaling policy. So what it will do, if you select this combination, what it will do, suppose if you try to load the data around 10 TB of data into a Snowflake, 10 TB of data load. 10 TB of data. Fine, this is one of the scenario. If you are trying to load a 10 TB of data into your Snowflake, So what it will do, if you select as a, if you create your virtual warehouse with the multi-cluster warehouse, along with the mode as a auto scale, and then scaling policy as a standard, and if you select the minimum cluster is 1 and then maximum cluster is 5, what it will do internally, before loading a process, before loading a data, internally it will calculate. So how many clusters are required? How many clusters are required for this process? First, it will start with the 1. Directly, it will not start with the 5. It will start with the 1, and then it will start processing it will start loading the data. If the minimum cluster is not sufficient, minimum cluster 1 is not sufficient, and then it will increase the maximum clusters to 2. And then even 2 is also not sufficient, and it will increase to 3, and it will increase to 4, and it will increase to 5, like that. So based on the requirement, based on the workload, based on the data processing, based on the data load, the maximum clusters will be increased. Maximum clusters will be increased. Maximum clusters will be increased. So this is the one case data load. Suppose you are submitting complex SQL code. You are submitting complex SQL code. Around 10, you're submitting 10 complex SQL code to execute the SQL code and then to retrieve the data from the Snowflake. So here also what it will do, so it will calculate internally. So when you submit, suppose the user name called XYZ, he has submitted around 3 queries. The user name ABC, he has submitted 4 queries. Another user has submitted 3 queries. So multi-users are submitted to Snowflake to execute their queries. Totally, we have 10 queries in the queue. So based on the workload, based on the complexity of the SQL code, then internally the multi-cluster warehouse will calculate that how many clusters are required for this 10 queries. Then those many clusters will be increased one by one. If those SQL queries are required maximum number of 5 clusters, 5 clusters, then it will increase the 1 by 1 plus 2, 2 plus 1, 3 plus 1, 4 plus 1, like that. So based on the workload and then based on the data processing, based on the data load, it will calculate and then it will increase the number of clusters. So you can call it as a clusters or a servers. You can call it as a clusters or a servers. It will provide the hardware resources to your actual process. So overall, what is the meaning of this mode equal to auto scale and then scaling policy equal to standard means? So based on the requirement, the maximum number of customers will be added one by one based on the query or then based on the data. So this is about the auto scale and then standard. This is clear or not, guys? If you clear this, then you will be understand further points. If you don't understand, then I will repeat once again. Tell me, confirm me, guys.
Good,
If you
sir.
are understand, sorry.
So cluster means the space, no, virtual space, where we data stored, like
No,
this.
not in a virtual. No. Sorry. You see, clusters mean. Suppose I will give you example. Just compare for comparison. This is not in a data storage component. Virtual warehouse. This is a completely your hardware component to your Snowflake. Let's consider. So in your system, you will be having the RAM, right? RAM.
Right. Yes.
Suppose if your 4 GB is if 4 GB RAM is not sufficient, then what you will do?
We will increase the RAM
to 8 GB. And then
yes.
The motherboard CPU capacity is not sufficient. What you will do?
We will increase the capacity of the CPU.
Like that only. So the multi-cluster warehouse or single cluster warehouse, purely hardware component. If
Okay.
your existing warehouse is your existing warehouse size is not sufficient, then you will increase the next size like that. This is not a storage scope. This is completely hardware component. I'm repeating again and again. Fine.
Okay. Yeah.
This point is clear or not clear? If this is clear, then I will go with the auto scale and then economy.
Explain about one second about standard.
Your voice is not clear.
Sir, just once again explain this standard concept.
Standard and then auto scale and then standard. Auto scale and then standard.
Scaling policy standard. Only that.
No. Scaling policy standard. This is the, like, not only a scaling policy standard, the combination of the mode and then scaling policy. It will not come only a standard. So the combination of mode, if you select auto scale, the scaling policy here, I will tell you. That's okay, fine guys. If you ask me a number of questions also, not a problem. But the thing is, you guys need to understand. See here, the mode, what I said, the mode auto scale. Agree? Mode auto scale. Agree? Say yes or no?
Yes.
And then maximum number of customers, minimum customers, I have selected 1 to 5, whatever you select. Agree?
Yes.
And then I have self scaling policy standard. Agree?
Correct.
So you can't select only a standard or you can't select only auto scale. This is a combination. So what is the meaning of this overall? I will tell you in one point. So based on the workload, based on the data load, based on the query processing, based on the data processing, your maximum number of customers, if you define as a maximum number of clusters to 6, so first it will check with the minimum. So it will check whether the workload or a data processing or a data load is sufficient with the one cluster. It will check. If it is not sufficient with the one cluster, it will increase to, first it will internally, it will not internally it will increase to 2. If this is not sufficient, internally it will increase to 3. Internally it will increase to 4. Internally it will increase to 5. Internally it will increase to 6. As you have defined as a maximum clusters 6. Is that fine or not?
Okay.
And then even for your queries also, so this is about a auto scale and then standard.
Right.
In case
So,
of auto scale and then, yeah.
So when we will decide that with the auto we can use the standard or economy maximum.
I will tell you. So I will tell you the differences. So standard auto scale and then standard auto scale and then economy. Then we will come to know what, in which situation we are going to use these things and all. Fine.
And the cluster which means 1 to 5 that is automatically increase as per the data load, or we have to increase our like whenever we have a more number of data.
No. See, while creation of a multi-cluster warehouse, you will define like this: 1 and then 6. You will give the maximum number of clusters. You will give the 6.
Okay.
Fine.
Means defaultly we provide 1 to 6, right? Likewise.
First, you will provide the 1 to 6.
Okay.
What your Snowflake will do based on the requirement, as you have created this maximum number of 6, even though you have provided a maximum number of 6, it will not use the maximum number of 6 customers, because everywhere the costs are involved. If you select the 6, the different size. If it is using the 2, different size. So to save the cost, first it will go with the minimum number of customers. No, minimum number of clusters. Fine.
Right.
So based on your data processing, even though if you select a maximum number of clusters, it will not directly go and then use the maximum number of customers directly. It will start with the 1 by 1. If the things are not sufficient, then it will go to the 6.
Okay.
Is clear or not?
Yes.
Still confusion, huh?
Miss, is internally went to miss one by one, or we have to?
No, internal. No, that's not internal. See, you defined 6 maximum number of customers 6. Okay.
Then
You
internally
defined maximum.
the data.
No. You have created a virtual warehouse. 1 second.
Right. Yes. And sir, this is you're doing on the app.snowflake.com.
Sorry.
This is you are creating the warehouse at app.snowflake.com, right? Yeah.
No. That I will show you. That I will show you. How do you create account those things and all. Okay. I will show you how do you create those things and all. Don't confuse with that.
Miss, my question is only that whenever we define 1 to 6, then
Okay.
as per the data, means the Snowflake internally means increase the suppose we have 10 TB data, then we will we will use only one virtual warehouse, only one. Then if
Sorry.
it is 0.
See, I have created this multi-cluster warehouse.
Okay.
Fine. Multi-cluster warehouse. Edit. See, you are able to see the sample multi-cluster warehouse, right? Sample multi-cluster warehouse. Just now I have created.
Yes,
Fine.
yes. Yes.
I have created sample multi-cluster warehouse with these many details. What are the details I have given? Just let me know.
1 to 6, 10, and standard. Yeah.
I have given these many options. What is the meaning of this means? Directly, it will not use the maximum number of customers. Directly, maximum cluster, it will not use the maximum clusters. It will use one by one. If the things are not sufficient, then it will go into the 6. Fine.
Yeah, correct. That is okay. Okay.
Clear or not clear?
Yes, it's clear. Yes.
Now I will go with the one by one. Jayant.
Yes, sir. Clear, sir. Yes.
Jayant. And then Manohar. Manohar. What about Rajesh? Hello.
Sir, it's clear, sir, for me.
Right. Raju.
Yes, clear, sir, for me.
Fine. Then we'll go with the other option. So now we have selected standard, which is auto scale. Now we can go with the economy. Economy. Here also you will select, you will do the same thing. Here also you will select the maximum and then minimum number of clusters like this. What it will do, if you select the economy, in case of a standard, whenever you upload the data or whenever you submitted your complex queries, it will calculate and then it will increase. What this economy will do, suppose if you select a 10 SQL queries to your Snowflake, it will calculate internally if the 10 queries can be completed within the 6 minutes. If the 10 complex queries can be executed within the 6 minutes, then it will go with the existing clusters. If the 10 queries are not sufficient to execute within the 6 minutes, then it will increase the next clusters. I will tell you once again here. So based on the workload, based on the data load, it will increase the next cluster. Here it will wait for the 6 minutes. It will internally calculate by the Snowflake if the queries can be executed within the 6 minutes. Whatever the queries are there in the queue, when you submit, it will be there in the queue in the Snowflake. Whatever the queries are there, whatever the data load size is there, they can able to submit within the 6 minutes. Then it will go with the minimum number of cluster 1. If the things are not able to complete within the 6 minutes, then it will increase the next maximum number of clusters. This is about economy.
Okay.
Guys, clear or not? Tell me.
Yes. Means in this economy, whenever we select scaling policy and economy, whenever we run the queries, it will wait for 6 minutes approx. After that,
No. Internally, it will not wait. Internally, it will calculate whatever
okay.
you guys are submitted 10 queries. Internally, it will calculate. Okay. It will consider that I received the 10 queries. I can able to complete these queries within 6 minutes or not. Yes, I am able to complete these queries in 6 minutes. Then it will go with the minimum clusters. If these queries are not able to complete within the 6 minutes, then it will increase with the next maximum number of customers.
Okay.
Clear or not? Tell me.
Okay.
No. Still, if you have any doubts, ask me. Then I will tell you.
Standard is also increasing the cluster and economy is also increasing the cluster. The difference is only that thing. It's
Usually maximum number of customers. The concept is to increase the clusters based on the requirement. But the thing is, the economy is so based on the time, the 6 minutes.
Okay. Right. Yes.
Based on the time, 6 minutes. The major funda to declare or define a maximum number of customers to give a more capacity to your hard disk. So here is it will calculate internally whatever the queries are there in the queue. If I am able to complete those in 6 minutes, then I will use existing thing, or else I will increase the maximum number of customers, maximum number of clusters. That is the major difference here. But in real scenarios, we will go with this option only. This is the best practice.
Okay.
This is the best practice. And then what about third option is maximized. I will show you here. See, if you select maximized, there is no minimum and then maximum customers. There is no scaling policy. See here, if you select maximized, you will be having the only cluster option. Select some clusters option. So there is no scaling policy. Maximized means if you define clusters as a 5, please observe the difference and then make a note somewhere. If you define a maximized clusters equal to 5 means when you submit all these things, instead of increasing one by one, all the clusters are used for your data processing parallelly. All the defined clusters are used parallelly to complete your task. This is the major difference. So here, based on the capacity, it will increase in these two options. Based on the workload and capacity, the clusters are increased. Fine. So here in maximize and then clusters, it will be maximize and then clusters. It will be used parallelly. All the clusters at a time. Clear or not? But this is not recommendable. Because if you select very small query also, then it will try to use all the clusters at a time. When you use number of more clusters, when you use number of more clusters, then it will charge that amount onto your organization. So whenever you try to use minimum number of clusters and then minimum number of storage component, then it will charge that much of amount only. If you use more storage capacity and then more hardware disk virtual warehouse, then it will cost the more on your organization. Clear, guys?
Yes.
This is clear or not? Virtual warehouse or virtual multi-cluster warehouse? Guys? No.
Good, Shekhar.
Okay. So in single virtual warehouse, in clustered virtual warehouse, we have a common options, advanced options. I will tell you. Auto resume. Auto suspend. So this is the common for your single virtual warehouse and multi-cluster warehouse. What is this auto resume? Auto resume, yes. Auto suspend, yes. So here there is no option yes. You need to select this like this. Yes or no, like this. Fine. See, auto resume is nothing but let's discuss about auto suspend is. What is the meaning? Suppose this is your Snowflake session. This is your Snowflake session. Fine. And this is your virtual warehouse. Your virtual warehouse. You created recently, right? This one, guys. Sample multi-cluster warehouse recently. Just now we have created this one. So what it will do? Auto suspend. If after 10 minutes, if you give it 10 minutes here, auto suspend, yes. After 10 minutes, if you are not using your virtual warehouse, then it will go automatically into suspension mode. It will go automatically into suspension mode. When it is going into suspension mode, then the charges are not applicable. Charges are not applicable, and then you are saving cost to your organization. Fine. So this is the beautiful option actually. If you are working continuously, then it will be in active mode. If you are not working, continuously 10 minutes, then it will go into a suspension mode. And then again, when you restart your session, then it will come into this one auto resume. Automatically it will resume, and then it will active. So what is the purpose and then what is the meaning? What is the benefit of this means? See, you are using your Snowflake for continuous 1 hour. So you kept aside your work and then you went outside. So after 10 minutes, so whatever you used for 1 hour, then it will charge for you. Whenever you kept aside and then you went outside, after 10 minutes, automatically it will go into a suspension mode. So at that time, what it will do, it will start to charge on you. Then it is saving cost for you. So that is the beauty of the Snowflake. Whatever you use, you are paying for that only. So if you are not using continuously for 1 week, then it is not going to charge on you. So this is the beauty of your Snowflake. Have you cleared these options, guys, or not?
Yes. Yes.
Yeah. So whatever I have shown you, how do you create a virtual warehouse? This is so we will create again. Just this is the theoretical part. The theoretical part. So this is the syntax to create the virtual warehouse. This is the SQL syntax to create the virtual. We will create one by one. Just this is a theoretical party, theoretical discussion. If you are not clear on this thing, just let me know. If you are clear, then so we will close the session and then we will continue tomorrow with the pricing, how the prices are applicable on your Snowflake when you are using, and then we will see the Snowflake editions by tomorrow. If you are clear, then okay. If you are not clear, just ask me. Then we will discuss all these things. These and all very much important concepts. You need to understand. You need to make a note. You need to remember. You will get a questions, interview questions on also on this concepts. Guys, clear or not? Hello.
Clear. Clear, sir.
Yeah, clear, sir.
Okay, super. If you have any doubts, you can ask me so that we can discuss.
Today only I joined first time. Previous classes, how many classes, sir, previously happened?
May I know your name?
My name is Rajesh Kumar.
Rajesh. That's fine, Rajesh. Whatever happened in previous class, then I will try to provide you the things. Just whatever we have discussed, theoretical things we have discussed. Continue with that.
Yeah.
Then whenever I get a time, then I will let you know all these things. Okay?
Yes, sir. Yeah, okay, sir.
So we have started with the basics and then the theoretical part. We have not started any like practical things. Just continue with this. Continue with this, then we will proceed. No, not a problem.
The duration, how many days, sir?
35 classes, Rajesh.
Okay.
Guys, any doubts?
No, sir.
Shall we close the session and continue tomorrow, same time?
Okay, sir.
Fine. Thank you, guys. We will meet tomorrow.
Yeah.
Okay, sir. Thank you.
Bye.
Yes.
So you need to contact the institute for the notes.
Okay.
They will give you.
Okay.
Fine.
Yes.
Thanks.
Bye.
Thank you.
Virtual warehouse will be charged based on the credits. Nothing what? They will measure the charge or cost. So based on the number of credits you use, suppose if you use X small virtual warehouse, so for 1 hour they will allocate you 1 credit. For 1 credit, how much they need to pay? How much they need to charge? They will see for 1 credit $2.7, $4 for different edition, $5.4 into another edition. Suppose if you use large, for 1 hour they are going to consider 8 credits. 8 credits into $2.7 for this edition. 8 credits into $4 for this edition. 5.4 into 8 credits for this edition. So based on that, they are going to charge you guys. Have you clear about this virtual warehouse calculation or not? Tell me.
Yes.
Confirm me, everyone. If you clear, then I will proceed further.
Yes.
Clear, right? So this is about the hardware component usage calculation. What about the storage? See, if you have taken Snowflake subscription. Suppose let's consider this is the January month. So your organization has assumed that the business is going to start from the January, but unfortunately the business got delayed. Already you have taken the subscription, but you are not using. In such case, you need to pay $25 per month if you are not using anything, but you have taken a subscription. And or if you have taken the subscription and you have started to use your Snowflake. In this case, for 1 TB you need $2. For 1 TB you need to pay $40 per month. If you use 100 TB, 100 into $40 per month you need to pay. So the cost will be in two ways actually. You need to pay for the storage and you need to pay for the compute virtual warehouse. So this is the way they are going to. This is the way they are going to charge you guys. Is this clear or not? So this is minimum $25 you need to pay if you are using. If you are not using, suppose if you are using, you started to load the data, so you need to pay $40 per TB. If you use 500 GB, then it will be divided into that part. So like that it will go. So this is about the pricing details on your hardware resources and your storage component. Clear or not?
Yes.
Yeah. So these are the these are the different virtual warehouse sizes. These are the different virtual warehouse sizes. So these are the credits. These credits are very much important. So based on these credits, they have already defined. Boss, if you created your virtual warehouse with the medium size, so in this case, we are going to allocate you 4 credits per hour and then 4 into, so based on the addition and then the $2.7 like that they are going to charge you. So this is very much important. You have to understand what is the different size of warehouse sizes and what are the credits, how they are going to start pricing on you. So this is about the pricing. This is about the pricing. If you have any doubts in the understanding on the pricing, just let me know. We will discuss and then we will proceed further. If you are clear, just confirm me. Then we will discuss next topics. And also, always I am trying to tell you, please make a note somewhere as a running note. Sure.
Yes, sir.
Guys, clear or not clear?
Yes, sir.
Okay, fine. Then we'll go to discuss the different editions are available in the Snowflake. Different editions. We have 4 editions actually: standard, enterprise, business critical, virtual private. So I'm repeating once again. So you need to make a note also. So we have a standard edition, we have an enterprise edition, we have a business critical edition, we have a virtual private edition. So these are the 4 types of editions we have in Snowflake. In general or in projects, we are using this business critical. Edition for our business purpose. We are using this business critical for our business purpose in our companies. Then we'll see what are the options are available. What are the different benefits or great features are available in the each editions. The standard is very basic edition. Here, whatever the data is you are going to store, that is in a encryption format. Time travel is up to 1 day. Now, the time travel is one of the great feature in Snowflake. What is the meaning of the time travel? Time travel means, suppose already I have explained in very first class, but let me repeat that one. Time travel nothing but if the data is modified from the table. So after modification of the data from the table, so you came to know that. So this is not the whatever you have done the modification, then that is not that is not a good modification. You need to restore the original data into your table. So in such scenario, in Snowflake has provided you an option, the time travel option. Nothing but you can go back to the history of the table, and then you can bring the original data and restore the original data to table. So in the standard edition, this history will be available for only one day. So suppose if you crossed, no, if you done the modification to the table today 6 o'clock, till tomorrow 6 o'clock, you can able to go to the history of the table and then bring the original data and then restore the data. It will available for only one day. If you cross that one day, then it is not possible. And then what about the disaster recovery? Disaster recovery, nothing but suppose if databases go offline, then you can able to bring that into online. What about this data share? Data share nothing but a secure data share. So you can able to share the data between the Snowflake accounts. This is about your standard edition. Coming to the enterprise edition, whatever the features are available in the standard, that will be available. That is very basic. Second one is multi-cluster warehouse. Yesterday we have discussed single warehouse and then multi-cluster warehouse. In standard edition only you can work with a single warehouse. This enterprise edition will be supporting the multi-cluster warehouse also. This time travel in enterprise edition will be there for 90 days. In case of standard, time travel will be available only one day. In case of enterprise, time travel option will be around till 90 days. So this is a great feature actually. So suppose 90 days means if you have done your modifications today, till 90 days, if you want to bring the data, then it will be available for the 90 days. So within the time, anytime you can able to go back to the history of the table and then bring the data. And then next, what is this materialized views? Materialized views, one of the concept in Snowflake, which is used to improve your improve the performance of your SQL query. Suppose your select statement is taking around 5 seconds to return the data. On top of that, if you create a materialized view, then you can able to bring the data in within 1 second. The beauty of this materialized view is it will improve the performance of your SQL query. Where your SQL query is taking 1 minute, but your materialized view will give the result within a fraction of seconds. So that is the great benefit of your materialized view. Search optimization, column level security, these things are provided in enterprise option. In business critical, so whatever the features are available in the enterprise edition, by default that will be there. Additionally, all the objects, all the things are encrypted everywhere. All the options, whatever you are going to create the objects, those are encrypted everywhere in the internally. We can't see those encryption and all, but internally it is happening. So that is a great feature. What already enterprise edition has the so many features. Those features are available with the business critical plus this data encryption everywhere, and then failover and then disaster recovery. So failover and then disaster recovery, nothing but if your database is crash, and then you can able to bring that database into online. So this is the great feature in the business critical edition. What about the virtual private? All business critical features are available in the virtual private, and then the extra is you need to create a separate environment, separate servers for different environments. Suppose if you are maintaining QA server, if you are maintaining testing server, if you are maintaining dev server, if you are maintaining production server, so for that you need to create a separate servers in your virtual private. So this is about your Snowflake editions, guys. Any doubts in this? These are some theoretical parts. You will get the interview questions. What are the different types of editions are available in Snowflake? and explain them. And also you will get the what is warehouse, what is multi-clustering warehouse, and what is the Snowflake architecture, how many layers are there, what are the functionality of those architecture. Can you explain all those things? These are the theoretical concepts. So you have to, for sure, you have to remember, understand, and explain thoroughly. Whatever we are discussing in the sessions, if you understand that and explain it clearly, whatever we have discussed here, that is 100%, 1000% more than enough, guys. That's why I am asking you. I will share you the note. I will share you the note along with me. You also prepare your some points in your notes, so that you will check the material and then you will check the note. So you will become a comfortable. If you get any doubts, again you will come back to me and we will discuss on the same topic, so that you will become a comfortable. So this is about the additions, guy. Any doubts? Let me know. Any doubts? Let me know. Just open your mouth, guys.
No, sir, but I wanted to know, in a typical real-time environment or a real-time project, typically a dev or QA or a production environment, what are the additions might be there? I mean, will be there. Whether the dev will be having only standard edition, or whether the QA having enterprise edition only, or the production might.
Usually in our real scenarios, in our organization, we all are using business critical for all the requirements.
Okay.
Next question. If you don't have any questions, then we'll move into another topic to discuss.
No, sir. Understood.
Fine. Yeah, then we'll go. How to connect to Snowflake. Web user interface. Second one is NoSQL through the DOS command. So we can able to connect your Snowflake. You can able to connect your Snowflake using your web user interface, or using Snowflake, or NoSQL using DOS command. And also, apart from this, we have some other options also, but majorly we are using these two options only. Some other options also available: JDBC drivers, ODBC drivers, those things and all. But in real-time scenarios, as per my experience, we have used only these two options. Then, as part of our regular classes, daily we are using this web user interfaces, this NoSQL and then DOS command things. We will be having the one session how do we use this NoSQL. Then now we'll see how to create the Snowflake account. Fine. You need to follow the steps and create yourself. And then we'll explore what are the options are available in your Snowflake account. Then go to Google. So here, make a note somewhere. Snowflake.com. Guys, have you make a note? Snowflake.com.
Yes.
I need confirmation from all, because you need to create account from your end. This is the free account. This is a free account. It will be available for the 1 month. You can practice in that environment. You can practice in that environment. You need to create. You can create, which is very easy step. You can create from your end also. Just you need to follow what I am doing, right? Just this is snowflake.com. Enter the snowflake.com. Then you will get into this home page. Click on the start for free. Click on the start for free. So here, provide your all the details. First name, I will give the Durga Soft. Durga Soft. Email ID, I will give my email ID. It will go into that. I will give the company name as Durga Soft. Role you need to select consultant. Location you need to select as a India. Guys, are you following or not?
Yes, yes.
Yes, yes.
So you need to give your personal details here. So once you have given everything, just continue. Click on the continue. See here, you need to select edition, standard or enterprise or business critical. I am selecting a business critical. You need to make a note down. You need to select. You need to select a business critical option. You need to select a business critical option. This is the option to select the edition. Once you select the business critical, this is the option to provide the select the cloud provider. You need to select the AWS. Guys, you are following or not?
Yes,
This
yes.
funds.
Yeah.
Super. So you need to select the AWS. See here, it is asking continental information. So as we have selected India, just select this Asia Pacific, Singapore. Then click on the get started. Click on the get started. Click on the get started. Now it will ask this many options. You can skip this one. You can skip this one. You can skip this one. See now, you are now signed up. An email to activate your account has been sent to your email ID. I will log in into my email ID. There you will get one link to activate the account. Snowflake.com. Activate your Snowflake account. Click on this. Click to activate. Click to activate. Then it will navigate to this page. Now give the username and then password. So this is the key here. You need to make a note this username and then password. I will give the Durga Soft user 11. One second. So you need to give the username and you need to give the password and confirm password and then get started. So this is your home page of this is your home page of your Snowflake account. You need to make a note down like this. This is your account URL. This is username. This is password for your account. You need to save somewhere so that you can able to log in daily and then work. So this is the your when you create an account, then you will get this page at very first. Have you make a note down all the steps, guys?
Yes, sir.
See, when you get here this option, first option is worksheets. If you click on this worksheet, see here, you will have a plus worksheet. If you click on this, so from this option, from here you can able to query your SQL queries in this area. So this is one of the option. So worksheets where you are going to write your SQL queries. Next, data. So here you can able to create the database. Fine.
Yes.
So here if you want to create any new database, you can able to create new database. If you want to create any schemas, then you can able to create the new schemas from here. Like that. See, first one is worksheets is important, data is important, and then this. In admin, here we have warehouse option. Here you need to create your warehouse. So these are the three options you have to understand. So once go into your worksheet, then click on this latest one. So here you can able to create your own database. Create database sample database. So here you can able to see your sample database like that. So for now, just whatever we have followed the steps, you create from your end and then start exploring on the things. Whatever you can able to explore, you can explore, and whatever you need to understand, you can understand. So from tomorrow onwards, we will start using the coding and then the actual Snowflake practical sessions. But before that, you need to create an account and be ready with, align with me, so that whatever we are going to discuss in the session as a theoretical part and then coding part, I am going to share with you. Then you can able to practice from your end also.
Okay.
Guys, let me know if you have any trouble in understanding how to create the Snowflake account or something else. Why I am stopping till here means, at any cost, 100% you need to create account today. While coming to tomorrow session, you have to be ready with your account. So only after completion of the tomorrow session, I am going to share with you all the code, all the things, so that right immediately you can able to do the practice. Next, if you are not creating, if you are unable to create the account, if you are not able to create the account, you are not ready, then you are lacking, and then you are not able to do the practice, and then it is problem for you. So that what I am suggesting you, whatever the queries, whatever the difficulties you face, you need to at any cost create the account and be ready with the for tomorrow's class. That's why I am stopping the session here. Fine, guys.
Okay, sir.
Any difficulties
Okay,
here?
sir. No, sir.
No,
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 sir.
right? All good.
Yes, all good.
Tomorrow we will meet at same 6 a.m. guys.
Okay, sir. Yeah.
Fine.
Yes.
Yeah.
Okay. Then we'll close the session for today.
Yeah.
Okay.
Thank you. Yes.
Thank you. Bye bye.
Uh,
Just as before going to proceed, just let me know if you have any doubts. Jayant, Manohar, Nitesh, Raju, you all guys are in yesterday's part of yesterday's class, right?
yes, sir.
Yes.
Yes, sir.
Just yes, any doubts in understanding of the definition of snowflake?
No, sir.
So we have discussed basic level of information yesterday.
Yes.
Any doubts?
No.
Right. No, no, good.
No. Okay, super. One second. So we will discuss today uh, architecture of the snowflake. Architecture of the snowflake. One second. Guys, actually, we have a three layers in snowflake architecture. We have three layers in snowflake architecture. One is cloud service layer. Another one is query processing layer. Third one is database storage layer. Let me repeat once again. One is clouds. Guys, just I am suggesting you and recommending you after the each and every session, whatever we are going to discuss, the theoretical part and then code part, I will share you end of the session to all of you to your personal mail IDs. At the same time, just please prepare some running notes from your end also, so that it will be easy to rewind the things. Just make some notes from your end also. Fine.
Sure.
Yes.
Okay. Yeah. So we have a cloud services layer, and then query processing layer, and then database layer. I am repeating once again. So why I am repeating once again and once again? This snowflake architecture is very much important. Damn sure you will get one or two questions from the snowflake architecture in the every interview, wherever you go. in all the companies. That's why I am repeating. So we have a cloud services layer, we have a query processing layer, we have a database storage layer. Now we will discuss one by one. So what is this database storage layer will do? What is this database storage will do? Storage component is this is a one of the database storage component. This is one of the component of the Snowflake. Nothing but, so we have a like storage and then compute component like that. This is the storage component of the Snowflake. And so whenever you load the data into a Snowflake, automatically the data will be stored in a continuous micro partitions. Guys, what is the meaning of this micro partitions means? See, if you have a some 2 TB of CSV file, 2 TB of CSV file in your source system. When you load that 2 TB of CSV file data into a Snowflake data warehouse, automatically that data will be stored in the tables. And then from the tables in a database storage layer, in storage component, so we have a micro partitions. Where your business data is going to reside into the component. So the least component of the storage layer in the Snowflake is micro partitions. When you store your data in a Snowflake, automatically the data will be stored into a continuous micro partitions. Each micro partitions will be having the size 50 to 500 MB. Fine. So apart from these micro partitions, the data will be stored in the columnar format. Do you know what is the meaning of this columnar format? Yes.
Means column format.
Yeah, column format is. See, first let me explain you what is the meaning of the micro partition, how it looks like. See, this is the micro partition structure. I will tell you what is the advantage to have the data in a micro partitions, and also what is the advantage to store the data in a column format. See, if you speak about the traditional database or a data warehouse, data will be stored in a row format. In our traditional data warehouse or a traditional database. For example, traditional data warehouse, if you consider a SQL server, where in a SQL server RDBMS or else in a SQL server data warehouse, the data will be stored in the tables in form of columns and rows, and then so the data will be stored in the form of the rows in a traditional database or a traditional data warehouse. In case of a Snowflake, the data will be stored in a columnar format. I will tell you that one. See here itself the data. I will tell you. See, this is one of the example. This is the one of the example of the table. So we have a column called type, name, country, date. The data is stored in a. So this is the traditional structure of the table. So data is stored in form of a column, and then rows. See, we have a type column, name column, and then country column, and then date column. When the data is loaded into the Snowflake, the data will be stored in a continuous micro partitions. This is the one micro partition. This is another micro partition. This is another micro partition. Within this micro partitions, your table data is going to loaded into multiple micro partitions. If you see here, the column type, name, and then country, date. So this is our traditional structure. In case of your Snowflake, see the data is storing in a micro partitions in column format. See here, the type is here. Type is one column, and then name is another column. Country is another column. Date is another column. See here, type, name, country, and then date. This is a row format. So this is a column format. So your first record first record type is 2. See here, type is first record is type is 2. Second column, name is A, and then country, first record is UK, and then date, first record is 11/12. So what is the advantage of this having the columnar format means, if you want to search a data, instead of searching a whole rows in a whole columns, just it will traverse only in single direction instead of checking the all the data from your all micro partitions, so that you can able to retrieve the data in a very faster. As I mentioned earlier, the data will be stored in a micro partitions and compressed way, and then optimal way. So this is what you can able to pull the data very fast from the Snowflake. See here, suppose uh, if you want to search, like type equal to or name equal to y, see y is available in micro partition 3, and then micro partition 3. So if you write a query, select star from table where name equal to y, so the value from the name column is available in the micro partition 3 and then 4. So what it will do, if you hit a query into the Snowflake data warehouse, instead of searching all the micro partitions, it will go into the particular micro partition in a column format. It will go into the particular micro partitions, and then it will retrieve the data from the SQL from the Snowflake data warehouse for you. So what is the benefit here? Suppose consider for your one table, if you have a n number of micro partitions, the data is table related data is stored in n number of micro partitions. If you are searching for the particular set of the result set, instead of searching the n number of micro partitions, directly it will go into the particular micro partitions, and then it will retrieve the data. So that what is the benefit here? Instead of searching the all the micro partitions, it will go into the particular micro partitions, and then it will retrieve the data, so that you can consume the execution of the time of your SQL code. Then how this Snowflake will know? How this Snowflake will know? If you write a select star from table where name equal to y, then it will go into the only particular micro partitions. How the Snowflake will come to know that the